All right, so if we are going to solve this equation, step one, you actually have to distribute the x through so that you get a quadratic equation. Now, if I'm going to factor this, when you factor, you have to set equal to 0. So I would add the 1 to the left-hand side. A trinomial, right? There's 3 pieces. So trinomials, you multiply to this third term, but the numbers also have to add to the middle term. In this case, it is not possible because nothing that multiplies to 1, which is only 1 and 1, can add to 7. So factoring is not an option on this one. If I wanted to do completing the square, when I distributed, it's actually set up nicely, because remember, completing the square, you want the letters on the left, the whole number on the right. But next step is to take that middle term, you cut it in half and you square it. When I cut 7 in half, I get a decimal. So that means when I square it, I'm going to get an even longer decimal. And that's not going to be fun to do. So completing the square is not a good option for this one either. So really, your one option for this one would be the quadratic formula. So the quadratic formula, you need your equation set equal to 0. So I'm going to use my rearranged format for my first box over here. And that way I can identify the 3 terms. Remember, a is always the coefficient in front of the x squared, b is always the coefficient in front of the x term, and c is always the whole number at the end. So I can plug 1, 7, and 1 into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And then you simplify. So you can simplify under the radical in this one, and that would be 45. You can simplify the denominator and get 2. Now 45 is not a perfect square, but it can be reduced. Radical 45 can get broken down into radical 9, radical 5, which is just 3 radical 5. So your final answer would be negative 7 plus or minus 3 radical 5, all divided by 2. You can't go any farther because you can't divide the 2 whole numbers on top by the denominator. So that is your final answer. The next question is a proportion. You have to start by cross multiplying so you can actually get a quadratic equation. So x times x is x squared, then x times the 5 is 5x, equals, you do the other way, 2 times 6 is 12. And again, if I want to factor, I have to set it equal to 0, so I would subtract that 12 over to the left to create a trinomial. Now remember, trinomials, you are looking for numbers that will multiply to the third term, but add to that middle number. So if I make my list of factors that would multiply to 12, you've got 1 and 12, 2 and 6, and 3 and 4. Or subtracted any of these factors, they would not give me 5. There's no combination of these numbers that could ever add or subtract, so factoring is not an option here. So let's try completing the square. When I cross multiplied, it's already set up with the variables on the left, whole number on the right, exactly what we want. But just like the last one, when I go to take the middle term, cut it in half and square it, again, I'm going to have a decimal, which is just going to make the problem way too complicated. So again, quadratic formula is our best bet. So I'm going to use the form where I set it equal to 0. Then I can identify my a, b, c. Remember, a is always in front of x squared, b is always in front of x, c is always in front, or the last whole number. So if I plug in, again, the formula is x equals negative b plus or minus radical b squared minus 4 times a times c, and that is all divided by 2 times a. Go ahead and simplify it. You'd get negative 5 plus or minus radical 73 over 2. And that is actually your final answer on this one because we cannot simplify radical 73. It is not divisible by any perfect squares. Next question. X squared minus 81. So let's start by factoring. It is already equal to 0, and if I look, this isn't a trinomial, there's only two pieces. This is, remember, difference of two perfect squares. It's difference, subtraction, and both of these pieces are perfect squares. 81 is 9 times 9, and x squared would just be x times x. So you set up two parentheses, and it would be x plus 9 and x minus 9, and then I can make a t-chart to create equations using these factors and solve each of those mini equations to find what is called the zeros. So that is one method. I could do completing the square, but completing the square, not really much to do on this one, just because if I move the whole number over, notice there's no x term to cut in half and square. So it's probably not the best method to use on this one. So again, I'm not going to do completing the square, but I can do quadratic formula. Even though I'm missing that x term, it's still okay. A, remember, is always in front of the x squared. Now b is always in front of x, and since there isn't an x, that's going to be 0, and the c is always the whole number at the end. So if I go ahead and I plug in, remember formula is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Go ahead and simplify that. Negative 0 is just really 0 plus. We get, I plug that into my calculator, we get a big number, 324 divided by 2. Now 324 is a perfect square. So I can, again, make a t-chart on this and do two equations. One, do this with the plus, and the other side I'll do this equation with the minus. So x can equal 0 plus square root of 324 is 18 divided by 2. And the other one would just be 0 minus the 18 divided by 2. So you just use both signs to create the two equations. So 0 plus 18 is 18 divided by 2. I get my positive 9. And then 0 minus 18 divided by 2 is a negative 9. Next one, you have to distribute again, start to create the quadratic equation. You get x squared plus 2x equals 10x plus 10 plus 21. You can combine these like terms and get 31. And then you're going to move these pieces over because to factor, it has to be equal to 0. So I'm going to subtract the 10x and subtract that 31. So my trinomial would look like x squared minus 8x minus 31 equals 0. Now this one, again, it's not factorable. The nothing will multiply to 31. That would also add to 8, or negative 31 and negative 8. So I'm not going to do that method. But I can do completing the square because my middle term is an even number. So if I keep the 31 on the right, because you want variables on the left, whole numbers on the right to do completing the square, take your middle term, cut it in half and square it. So that is 16. So I'm going to add that to both sides. And the reason you do that is because now you have a trinomial on this left-hand side that actually can be factored. Negative 4 times negative 4 would give you positive 16, and negative 4 plus negative 4 would give you negative 8. So rather than write that out twice, because it's the same number, I'm just going to write it once, the x minus 4, and put a square to show that there should be 2 of those. Because then I can square root to get rid of that exponent, and then just add that 4 over to the other side. So I get 4 plus or minus radical 47. And I can't reduce radical 47, so that is the final answer for that. If I would rather use the quadratic equation, I would use the version where I had set it equal to 0. And that would mean A is 1, B is -8, and C is -31. And then my equation would look like a -8 plus or minus the square root of -8 squared minus 4 times 1 times -31, all divided by 2 times 1. And then I can go and simplify. Now, two negatives cancel each other out, so that's just a +8 plus or minus. If I type that in my calculator, I would get 188 divided by 2, which radical 188 can be reduced because 4 goes into it. So 4 and 47 make 188, which that would really just be 2 radical 47. So x equals 8 plus or minus 2 radical 47, divide by 2, and then I can actually simplify this more because both of the coefficient top can be divided by our denominator. So x equals 4 plus or minus 1 radical 47, which, same answer. So it didn't matter which way we solved it. And last but not least, final one. Again, to start with, you would want to distribute to create a quadratic equation. Factoring, you'd want to set it equal to 0. And a factor, easiest way to do it, if you can get rid of the coefficient in front of x squared, do it. And all these numbers are divisible by 2. So I'm going to divide everything by 2. That should be 2x. And then 40. Now, again, I am not going to be able to do this because all my numbers that multiply to 40, none of them would add or subtract to make 2. 1 and 40 don't make 2. 2 and 20 wouldn't. 4 and 10 wouldn't. And 5 and 8 wouldn't. Those are the only numbers that multiply to 40. So factoring is out. So instead, I'm going to do completing the square. And I'm going to use the version where I divided out the 2, because to do completing the square, remember, x squared has to have a coefficient of 1. So I'm going to do x squared plus 2x. And the whole number should be on the other side, so I'm going to move that 40 over, so it'll just equal 40. Then I'm going to cut my middle number in half and square it, and I'm going to add that to both sides. And again, we do that because now I have a trinomial that actually can be factored on the left-hand side. 1 times 1 gives me 1, and 1 plus 1 gives me 2. So x plus 1, and since it's the same number, I don't write 2 parentheses, I just write 1 with the little squared. And I can do that because now I can just square root, and there is no exponent anymore. It's just x plus 1 equals the square root of 4. And then just move that 1 over. It was a plus 1, so we would minus 1. And then plus or minus radical 41. And that's it. You can't reduce radical 41 because no perfect square goes into it. So that is it. And again, you could have used the quadratic formula. You don't have to get rid of the 2 in front. So I'm actually going to use the original one where I didn't divide out 2, but the one where I have it set equal to 0. Because with quadratic formula, it doesn't matter what your numbers are. A can be 2, it doesn't have to be 4, and C would be -80. So if I plug in, that would be -4 plus or minus the square root of 4 squared minus 4 times 2 times -80, all divided by 2 times 2. So x equals -4 plus or minus, that actually is a giant number, 656 divided by 4. But 656 can be reduced using 16. 16 times 41 works. So that's really 4 radical 41. And then you can actually do even more, because once I have this right now, I can notice that both whole numbers in my numerator are divisible by the denominator. So -4 divided by 4 is -1, and 4 divided by 4 is 1, which again, same answer as when I did completing the square, just a different method.